Electrical energy. Electrical energy. The work done by electric current is called electric energy. Here you have a battery. From the battery, the current flows through the resistor. In the resistor, the heat develops. The heat develops equals the work done by the current. When current flows, energy converts into heat, light, mechanical energy. The unit of electrical energy is joule. The electrical energy W equals VIT. V is the potential difference, I is the current, is the time of flow. Let us use the Ohm's law V equals IR in the above formula. When we replace V as IR or when we replace I as V by R, we get another two form of electrical energy. The one is the electrical energy W in terms of current and resistance is I square RT. The electrical energy W in terms of voltage and resistance is V square upon R multiplied T. Let us remember all these formula because based on depending upon the quantity given, we have to use any one of these formulae. Electrical power. The power. It is a rate of consumption of electrical energy. The power is a rate of consumption of electrical energy. Here you have the bulb. The power is given by the electrical energy divided by time. Its unit is watt. So P equals W electrical energy divided by time. P equals electrical energy divided by time. Let us substitute the electrical energy W equals VIT. So we get power as V times I. Now we can replace V as IR or I as V by R by using Ohm's law. So we get another two formulae. The first one is P equals I square R, the power in terms of current and resistance, and P equals V square upon R, the power in terms of voltage and resistance. Here, the resistance of the bulb from its rating. Suppose a bulb is given as 60 watt 220 volt. Then how we find the resistance of the bulb? This is the most important formula. R equals V square upon P. The potential difference for India is 220 volt fixed. Based on the power, it is 60 watt or 100 watt. The resistance of the bulb changes. More is the power and less is the resistance. Commercial unit of electrical energy. It is used in electricity bills. 1 kilowatt hour, 1 electrical energy equals 3.6 multiply 10 power 6 joule. 1 kilowatt hour equals 1 unit. How you get this value? The kilo is replaced by 1000, the watt is replaced by joule per second, and the hour is replaced by 3600 second. So we get the relation 3.6 multiplied 10 power 6 joule as 1 kilowatt hour. Heating effect of current. Joule's law. H equals I square RT. This formula that you have to remember because based on this formula, lot of problem will appear. It is used in electrical heater, iron box, and fuse wire. The heat what the resistors develop in a water or in any other material can be found by using a formula del Q equals ms del T. This formula will also be used along with the Joule's law of heating. Two bulbs are of 40 watt 200 volt and 100 watt 200 volt. Then the correct relation for their resistance is 4 options are here. So the relation between power and the resistance is P equals V square upon R. In two bulbs, the voltages are same. So P proportional to 1 upon R. So R proportional to 1 upon P. That means more is the power, less will be the resistance. So 100-watt bulb has more power and it has less resistance. So option B is correct. Let us learn. So P equals V square upon R. So R equals V square upon P. As P is constant, R proportional to 1 upon P. Therefore, power of 40 is less than power of 100. Therefore, resistance of 40 is greater than resistance of 100. So, option B is correct. At same voltage, lower the power, higher the resistance. Fuse wire is a wire of, please remember the property of fuse wire. The fuse wire must have high resistance and low melting point. Then only it will break the circuit. Option A, high resistance and high melting point. The high melting point is wrong. So option A is wrong. Option B, high resistance and low melting point. So option B is correct. Then option C, low resistance and low melting point. Low resistance is not possible. That will not work. So option C is wrong. So option D, low resistance and high melting point. It's absolutely not correct. So let us learn the subject. Heat produced is proportional to I square R. Therefore, higher the resistance, more will be the heat produced. Then, the fuse must melt easily to break the circuit. So, it must have very low melting point. So, fuse means heat fast plus melt fast. In India, electricity is supplied for domestic use at 220 volt. It is supplied at 110 volt in USA. If the resistance of a 60-watt bulb for use in India is R, the resistance of a 60-watt bulb for use in USA will be. Good. 4 options are here. So the relation is the power equals V square upon R. So R equals V square upon P. In both the countries, the power is same, 60 watt, 60 watt. So R is directly proportional to V square. So R prime divided by R will be 110 square divided by 220 square. So in India, the resistance is 220 square divided by 60, and in USA, it is R prime equals 110 square divided by 60. So let us find R prime by R equals 110 square divided by 220 square. We get 1 upon 4. So option C is correct. A 5 ampere fuse wire can withstand a maximum power of 1 watt in the circuit. The resistance of the fuse wire. The power equals I square R. So R equals P divided by I square. P is 1 watt divided by I square is 25, because 5 into 5 it is 25. So the resistance equals 1 upon 25 equals 0.04 ohms. So option A is correct. Let us go properly. P equals I square R, then R equals P upon I square. The P is 1 watt, it is given, and the I is 5 ampere. So 1 upon 5 multiply 5 equals 1 upon 25. So the answer is resistance of the wire is 0.04 ohms. The option A is correct. An electric kettle takes 4 ampere current at 220 volt. How much time will it take to boil 1 kg of water from the temperature 20 degrees Celsius? The temperature of the boiling of water is 100 degrees Celsius. Good. Now we can find the power by multiplying the voltage and current. And next we can find the energy by using a formula ms del T. The mass of the water is 1 kg, the specific heat capacity of water is 4200 joules, and the rising temperature is 100 minus 20, it is 80 degrees Celsius. The time is energy by power. We use all these formula to find the answer. So let us start. Del Q is the heat developed, that's equal ms del T. The mass is 1 kg, specific heat capacity of water is 4200, the rising temperature is 100 minus 20. The answer is 33,360,000 joules. Good. Then the power is voltage multiply current. The voltage is 220 and the current is 4. So the power is 880 watt. Let us go with the time. That's equals the energy divided by the power. The energy is 336,000 divided by 8800, which is approximately 382 seconds. but we need the time in minute. So let us divide 382 divided by 60. We get approximately 6.3 minutes, which is option C. If the voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of rated value by which the power would decrease is. Here, the voltage drops by 2.5%. We are asked to find what is the drop in power. So, four options are here. Let us start. For a bulb, the resistive load is constant. R is constant. So, P equals V square upon R. So, when we go for percentage error, we get dP upon P multiply 100% equals 2 times dV upon V multiply 100%. So, the shortcut is if the voltage changes by X%, then the power changes approximately by 2x times. So, here the voltage drop is 2.5 multiplied 2, it is 5%, that is the power loss. So, voltage decreases by 2.5%, then decrease in power is 2 times 2.5, it is 5%. So, option C is correct. Two cities are 150 km apart. Electric power is sent from one city to another city through copper wires. The fall of potential per kilometer is 8 volt and the average resistance per kilometer is 0.5 ohms. The power loss in the wire. Here we have to find the total potential drop. V equals the potential drop per kilometer multiply the total distance. So 8 multiply 150, we get 1200. Let us find the total resistance. It is equal to the average resistance per kilometer 0.5 multiply the total length 150. So we get 75 ohms. Let us find current equals voltage upon resistance 1200 upon 75, we get 16 ampere. We have to find the power, that's equal to I square R. I is 16, R is 75. We are substituting this and going little calculation, we get the power as 19.2 kilowatt, which is option C. The charge flowing through a resistance R varies with the time t as Q equals AT minus BT square. Here A and B are constant. We are asked to find the total heat produced in R. The relation between heat and current is H equals I square RT. The relation between current and charge is I equals dQ by dt. So let us start. Q equals AT minus BT square. So I equals dQ by dt. When we differentiate AT, we get A. When we differentiate BT, we get 2BT. So current is A minus 2BT. Now, we need to know the limits. When Q is 0, the current is 0. Good. Second condition. When current is 0, right? Let us substitute A minus 2BT as 0. From this, we find the time as A divided by 2B. So we have now limits 0 to A divided by 2B. So the H is integration 0 to A divided by 2B I square R dt. Let us substitute the value of current here. I is replaced by A minus 2BT. So let us square A minus 2BT. We get A square minus 4ABT plus 4B square T square. Now let us integrate A square. We get A square T. Let us integrate minus 4ABT. We get minus 4ABT square divided by 2. When we integrate T square, we get T cube divided by 3. So we substitute upper and lower limit to get the answer. The lower limit is 0, right? H equals R, the terms are given. Then simplifying it, we get H equals A cube R divided by 2B. The option C is correct. Which of the following acts as a circuit protection device? Fuse, conductor, inductor, switch. When a current exceeds the safe limit, the fuse wire melts. This breaks the circuit and prevents the damage to appliances and wiring. Conductor. The conductor only allows current to flow, but it's not used for protection. Inductor. stores energy in magnetic field, not for protection. And next, switch. It is used to open or close the circuit manually, but not automatic protection. The fuse, it's a safety device which is automatic. Always remember that fuse works on heating, the effect of current. Let us learn the function of fuse. Protect circuit, melts when high current flows. Switch opens or closes the circuit. Conductor allows current to flow. Insulator blocks the current. Resistor opposes the current. Inductor opposes a change in current. Then the capacitor which stores the energy. So the right option is option A, fuse. 1 kilowatt hour is equal to, we know that 1 kilowatt hour is 3.6 multiplied 10 power 6 joule. So when we check all four options, the 36 multiplied 10 power 5 joule becomes 3.6 multiplied 10 power 6 joule. So option C is correct. Anyhow, let us see. Kilowatt hour equals 1000 watt multiply 1 hour. An hour is 3600 second. A watt is joule per second. Second and seconds getting cancelled. So we get 3.6 multiplied 10 power 6 joule. But to match with the options, we have 36 multiplied 10 power 5 joule. The option C is correct. A 100 watt 200 volt bulb is connected to a 160 volt supply. A 100 watt 200 volt bulb is connected to a 160 volt supply. The power consumption would be, four options are here. Then from the formula 100 watt 200 volt, we can find the resistance of the bulb. Now the same bulb is connected to 160 volt power supply. So the new power will be equals the new voltage square divided by the resistance. Now let us solve the problem. P equals V square upon R. So substituting P as 100 watt and V as 200 volt, we can find R. But in two cases, the resistance is same. So we go in a different way. As R is constant, P proportional to V square. Therefore, P prime divided by P equals 160 square divided by 200 square equals 0.8 square equals 0.64. So P prime equals 0.64 multiply P. P is 100 watt. Therefore, P prime is 64 watt. The option C is correct. A 4 microfarad capacitor is charged to 400 volt. If its plates are joined through a resistance of 2 kilo ohms, then heat produced in the resistance is. So, the energy stored in the capacitor is given by a formula epsilon equals half CV square. The value of C is 4 microfarad and the value of V is 400 volt. Let us substitute 1 upon 2. In the place of C, 4 multiplied 10 power minus 6. In the place of V, it is 400. On simplifying this, we get 2 multiplied 10 power minus 6 multiply 160,000. Then again, the epsilon becomes 0.32 joule. So the option D is correct. And please remember that the resistance value 2 kilo ohms does not affect total heat produced. It's only affect the rate of discharge. Total heat equals the initial energy stored in the capacitor. So they given the resistance value to confuse you. An electric bulb is rated 60 watt 220 volt. The resistance of its filament is. It's a very simple question. The power is given by V square upon R. Let us find R. R equals V square divided by P. The value of V is 220 volt. The value of P is 60 watt. Let us substitute this and we have R equals 220 multiplied 220 divided by 60. On simplifying, we get 484 multiply 100 divided by 60. So the final answer is 806.7 ohms. The option D is correct. A current of 2 ampere passing through a conductor produces 80 joules of heat in 10 seconds. The resistance of the conductor in ohms. So use the formula H equals I square RT. Here H is the 80 joule, I is the 2 ampere, Then t is 10 seconds. We need to find resistance. So let us start with the formula H equals I square RT. So R equals H upon I square T. Let us substitute H as 80 joule, I as 2 ampere, T as 10 seconds. So on simplifying this, we get 8 upon 4 equals 2 ohms. So option B is correct. A 5 degree Celsius rise in temperature is observed in a conductor by passing a current. When the current is doubled, the rise in temperature will be approximately, right. Here, 5 degree rise related with heat, the current is related with the heat. So those two heats are having two different formula. We have to relate those two different heat formula. Let us start. The heat energy produced when a current passing through the conductor is H equals I square RT. Then, due to rise in temperature, the rise in heat energy del Q will be equals ms del T. M is the mass of the substance, S is the specific heat capacity of the substance. Good. Then I is the current, R is the resistance, T is the time of flow. Let us relate these two equations. Del Q equals H. So we get ms del T equals I square RT. In this equation, M, S are constant, R constant, T constant. So we get del T is directly proportional to I square. Then let us go for the relation. Now the current is doubled and the new rise in temperature are asked. So del T new divided by del T equals 2I the whole square divided by I square. Now we get 4 upon 1. So del T new will be equals 4 multiplied del T. We know del T is 5 degrees Celsius. So 4 times of 5 degree is 20 degrees Celsius. That is a new rise in temperature due to double the current. So option A is correct. So current doubles, heat becomes 4 times, temperature rise also 4 times.